There are going to be times when you are given a formula and you have to solve that formula for another variable in the formula. So let's take a look at some problems here that involve those types of problems. Okay, so the first one says the formula is AB equals C, and it asks us to solve for B. Okay, so the idea here is we need to get the B by itself. So since I have A times B, what I can do is divide this side by A so that the A's will cancel and I'll just get B. Now if I divide that side by A, I also have to divide this side by A. So if you look down here, I divide both sides by A, and over here the A's cancel and just give me B, and on the right I have C over A. Now that's about as easy as I can make it to start with, but they do get a little more complicated. This one is probably the other end of the scale. It's fairly complicated. So here I have V equals 4/3 pi r cubed, and this is actually a geometry formula for volume, and it asks us to solve for r here. So what I want to do first is I want to get rid of this 4/3. Now I showed you a little trick earlier that if you want to eliminate a fraction that's multiplied by something, you can just multiply by the reciprocal of that fraction. So if I want to get rid of the 4/3, I can just multiply that by 3/4. Now if I multiply the right side by 3/4, I must also multiply on the left side by 3/4. So on the left side I'm going to have 3/4 times V, which can be written as 3V over 4. And on the right side, I know that when I multiply 3/4 times 4/3, that's just going to be 1. So I have 1 times pi r cubed. Okay, so now remember I'm trying to solve for r, so let's get rid of the pi here. So to get rid of the pi, I'm actually going to divide both sides by pi. So when I divide the right side by pi, then of course we know pi over pi is 1, and that'll just leave me with 1 times r cubed, which is just r cubed. Now I'm going to go ahead and write the r cubed over here on the left, and then I'll write what I get here on the right. So now remember, let's go back to where I was. I divided this side by pi, so I also must divide this side by pi. So I take 3V over 4, divide it by pi, and I get 3V over 4 pi. Now, that doesn't give me r. That tells me what r cubed is. So if I want r, I actually have to take the cube root of both sides. Now, the good news is when you take the cube root of r cubed, you get r. And then when you take the cube root of this, you just get the cube root of this. So the cube root of r cubed is r. So r would be the cube root of that entire quantity, 3V over 4 pi. Alright, next one. Here we have C equals 4y over m plus n. Solve for y. So what I'm going to do first here is I want to get rid of this denominator. So here's what I'm going to do. To get rid of this m plus n, I can multiply this by m plus n, like I'm going to do here. And when I multiply this fraction by m plus n, then I know m plus n over m plus n is just 1, and so that'll just leave me the 4y right here. Now if I multiply the right side by m plus n, I must also multiply the left side by m plus n, so that would give me c times m plus n. So now I have this, c times m plus n equals 4y. So I'm almost there. I need to get y by itself, I need to divide both sides by 4. So I'm going to take 4y and divide it by 4. That way I just get y by itself over here. And then if I divide the right hand side by 4, I must divide the left hand side by 4. So I'll take the c times m plus n and divide it by 4. Now I'm just going to turn it around and write the y on the left. So that's going to give me y equals c times m plus n over 4. So now I've solved that for y in terms of the other variables. Okay, here's another one. This one I want to solve for k. So what I'm going to do is similar to what I did over here. First thing I'm going to do is get rid of this denominator 3 by multiplying this fraction by r. The denominator r by multiplying this fraction by r. So I'll get rid of this denominator r, and by multiplying by r, because I know that r over r is just 1, so that's just going to leave me with k minus m. Now on the right I'm going to have q times r, so we can just write that as q times r. Now I want to get the k by itself. Now since I have k minus m, what I can do is just add m to both sides. So if I add m to the left, then minus m plus m cancels, and of course if I add m to the left, I must add m to the right as well. So that would give me qr plus m. So on the left, now all I have left is k, and that's what I wanted, equals qr plus m. Okay, now the next one, you'll actually, this will come in handy when you're working with lines. Here we have 4x minus 5y equals 8, and we want to solve for y. So what I'm going to do here first is I'm going to get rid of this 4x so I can get the minus 5y by itself. So I'm going to take the left-hand side and I'm going to subtract 4x on the left. That means I have to take away 4x on the right. Now, but when I subtract 4x on the left, the 4x's cancel, and I get minus 5y all by itself. On the right-hand side, I have 8 minus 4x. Now, to get y by itself, I need to divide both sides by negative 5. So I would divide this by negative 5, and then, of course, this by negative 5, this entire expression by negative 5. So let me get that out of your way there. Okay, so if I divide this by negative 5, I just get y, and if I divide this by negative 5, I get 8 minus 4x over negative 5. Now, I'm going to go ahead and break this up into two fractions. This can be written as 8 divided by negative 5, which is minus 8 over 5, and then minus 4x divided by negative 5. But if you take minus 4x and divide it by negative 5, it's the same as plus 4x divided by 5. So this can be written as minus 8/5 plus 4/5 x. This other one here is also a linear equation, and it says solve for x. So since I want to solve for x, I'm going to subtract 2y from both sides. Now, all through these lectures, I've been subtracting what's called doing this horizontally, where I subtract the 2y out here. Now, you could write it like this, where you subtract the 2y. This would be vertical. This is a vertical technique. But either way, when you subtract the 2y from both sides, you're just going to be left with 3x on the left, and then on the right side you're going to have 7 minus 2y. Okay? And then just like I did over here when I divided by negative 5 to isolate y, here I have to divide by 3 to isolate the x. So divide both sides by 3 and I'll get x on the left equals 7 minus 2y divided by 3. Well, I can break that fraction up as 7 over 3 minus 2/3 y, and by just breaking up the numerator. Now you'll probably recognize this one if you've ever taken a physics class or science class. This is the formula that converts Fahrenheit to Celsius. But what if we wanted a formula that converted Celsius to Fahrenheit? Well, then we could solve this formula for F. Now, since I want to solve for F, what I'm going to do first is get rid of this fraction. So I actually just wrote the problem down again here. So I didn't really have to write that, I guess. But anyway, I want to get rid of this 5/9. So remember the trick I told you earlier is if you multiply 5/9 by its reciprocal 9/5, well, then that's actually going to equal just 1. So that way, if I multiply this by 9/5, this will cancel and give me 1, and I'll just be left with the f minus 32. Now, if I multiplied 9/5 on the right, I must also multiply 9/5 on the left, so that's why I have 9/5 c. Now, so now I have f minus 32 on the right and 9/5 c on the left. So what I can do to get the f by itself is just add 32 to this. So I take the f minus 32 and add the 32, and that way it'll cancel the minus 32. And then I also have to add the 32 on the left, which will give me 9/5 c plus 32. So if you read this, I get 9/5 C plus 32 equals F, and of course I can write it this way as well. F equals 9/5 C plus 32. Okay? Now, right here, this is probably the most difficult one of all. I want to solve this for V2. So what I'm going to do here is, again, I'm going to get rid of this denominator by multiplying both sides by G. So if I multiply this side by G, then G over G is just 1, and then I'll have to multiply the left side by G as well. So I get PG equals just this portion, the V1 times V2 minus V1. Now, there's a couple of different ways you could approach this, but here's what I'm going to do. I'm going to take what I've got here, and I'm just going to divide both sides by V1. So I'm going to take this right-hand side and divide it by V1. Now, what that'll do is that'll allow the V1 here and the V1 here to cancel as 1, and so that way I'll just have V2 minus V1 on the right-hand side. And then since I divided the right-hand side by V1, I got to divide the left-hand side by V1, so I'll get PG divided by V1. Okay, so now I'm here, right? So now remember, I wanted to solve for V2. So all I have to do to solve for V2 is get rid of this V1 from the right-hand side. So I can get this, since that's a minus V1, if I actually add a V1 to the right-hand side. So here's the right-hand side. Then I can add V1 to that side as long as I add V1 to the other side. And by adding V1 to the right, the V1 and the minus V1 cancel, and I get V2 all by itself. Now this time I wrote the V2 on the right, but if you wanted to, you could turn that around and say V2 equals this stuff over here. So I just didn't turn it around this time. But that's how you solve these equations for unknown variables. So if you're given these formulas like this, sometimes you may have to take a formula and solve it for one of the other variables. Now on each of these, you actually were told which variable to solve for, but in real life it depends on what it is you're looking for. Like for instance here, I might have wanted to solve this for V1 instead of V2, or over here, well over here I only could solve it for F, but if you go to one of these others, like up here, instead of solving this for K, I could have wanted to solve it for M or solve it for R. But as long as you've got the formula, you can take these formulas and solve them for any of the variables that are listed in the formula. Okay, so that pretty much covers that. Now the next section I'm going to talk about is going to show you how to solve absolute value equations. So we'll do absolute value equations next, and then the last section for this chapter will involve word problems or applications of linear equations.